Hello again guys. So, another very interesting question in which we are given the reading of the oscilloscope to find the unknown quantity here, and that is the value of the capacitance which is inside the black box, and we just have the value of the peak to peak voltage across this resistor. Okay. So, how to use these values here? So, let me first convert this peak to peak voltage into the RMS value. So, in order to do it, let me use this V of R is equal to the 8.27 divided by 2. Okay. So, it would be the peak value because this is a peak to peak value, and at the end I have to divide it over this square root of 2. So, I will get here 827, okay, 8.27 divided by 2 into square root of 2. Okay. So, why to use this square root of 2? Because I have previously mentioned that Vrms is equal to the V peak divided by square root of 2, and using this similar concepts here, and similarly Vp is equal to the V peak to peak divided by 2. Okay. Putting it here, and then using this mechanism to find the values, the ultimate numerical values will be here. Okay. So, I have also mentioned all these concepts in our previous videos. So, now simplifying it, I will get, so 8.27 divided by 2. So, it is 4.135 divided by square root of 2, 2.92. Okay. So, that is basically 2.92 volts, and that is V of R. Okay. As I already know the value of VR now, so by using the voltage divider law in this circuit, I can see that V of R is equal to R divided by R plus X of L multiplied by what? Multiplied by the source voltage, and that is E. Okay. Now, putting their values here, what I will get, this will now, or rearranging it to find the value of X of L, what I will get, V of R, R plus X of L equal to R multiplied by E, or V R multiplied by R plus V R multiplied by X of L is equal to R multiplied by E, or to find the value of X of L, subtracting V R multiplied by R in both sides, what I will get, V R into X of L is equal to R multiplied by E minus V R multiplied by R, or from here I can also see that it will be R E minus V of R whole divided by V of R, and that is equal to the X of L. Now, putting values here in this equation, so let me call it equation A. Putting values here, what I will get, the value of R is given, and that is 10 kilo ohm, that is 10 into 10 to the power 3 for the simplicity. What is the value of E? E is also known, and that is 12 volts. 12 minus what is the value of V of R, the voltage which has been detected across this resistor. So, that is already known, that is 2.92. Okay. Whole divided by V of R. So, whole divided by V of R is 2.92. Okay. So, now let me simplify it. So, for simplifying it, let me first 12 minus 2.92. Okay. So, it will be this one, 9.08 and 9.10 to the power 4 into 9.08 divided by 2.92, or divided by 2.92, this is 3.10, and times power 3 multiplied by 10 into 3.10, or it will be 31 into 10 to the power 3, or ultimately it will be 31 kilo ohm. Okay. So, that is the value of X of L which I had to find out here. Okay. So, from our previous expressions, I know that the value of that is X of C. Let me now use X of C here instead of this X of L, because this is the capacitor. So, X of C is 31 kilo ohm. As I know that X of C is 1 over omega C, or the value of C is 1 over X of C multiplied by omega. Now, let me put their values. So, X of C is how much? That is 31 into 10 to the power 3. Okay. What is the value of omega? That is 2 pi into f. Okay. So, it will be 31 into 10 to the power 3 into 2 pi into what is f here. So, f is 40 kilohertz, 40 into 10 to the power 3. So, here it will be capacitance will be here, and that would be, let me move this 10 to the power 3, 10 to the power 3 is 10 to the power 6. So, 10 to the power minus 6 in the numerator, and here 31 into 2 pi into 40 is how much? 80 pi. Okay. So, now let me calculate it. 31 into 80 into 3.14, it will be like here, and taking reciprocal of it, what I will get? So, reciprocal of it will be this one. So, this is 1.28 into 10 to the power minus 4. So, 1.28 into 10 to the power minus 4 into 10 to the power minus 6. So, it will be how much? 1.28 into 10 to the power minus 10 farad. Okay. So, that is the value here, and in order to convert it into the nanofarad, what I can do here? Now, let me use here 0.128 into 10 to the power minus 9 farad. Okay. So, ultimately I will get here 0.128 nanofarad. So, that is the value of the capacitance or the capacitor which I had to find out. So, that is it for today, in which we have found out the value of the capacitor in this question. So, I will see you with some more question in our upcoming videos. Thank you so much.